Alright guys, let's get started on section 3 of unit 2. So there's a lot to this. You do need your calculators, so go ahead and get Desmos open, and if you have a handheld calculator, go ahead and get that out too. So we will be using these calculators. Alright, so let's get started on these notes. To write a linear equation when you know the slope and a point that it passes through, you will use the point-slope formula, which is looking a little messy here because I had a little oopsie, and it's not wanting to cooperate. Alright, that would be y minus y1 equals m, so the slope, parentheses, x minus x1. Okay, we're in business. Finally, my pen was giving me some problems. Okay. Examples of this would be when you have your point that you want your line to go through, you would identify those as x1 and y1, and of course that's m. So your first y is a placeholder, y minus 7 equals m. Oh, well, it would help if I substituted it for m, wouldn't it? M is negative 4, and then x minus negative 1 changes to a plus 1. Doop doop, yeah. Okay. Then, if needed, you can change this into and get y by itself, and get it in y equals mx plus b form. Let's go ahead and do that. So we would distribute this, and then we have to, of course, move the 7 over. I'm going to do those in the same step. Negative 4x, and then minus 4. Then opposite would be add 7 to the other side. And negative 4 plus 7 just needs to be simplified, which is positive 3. Okay, so there's your answer, also in slope-intercept form, which the math people in the math world really, really like that. For some reason, they just love this form the most. Okay. Why don't you go ahead and try the other one, and pause the video, and then press play when you're ready to see. So, here's your solution. Alright, so if we want to get the slope, and we have 2 points, remember that this is your slope formula. Lowercase m is slope, y2 minus y1 over x2 minus x1, which is rise over run, the change in your y's over the change in your x's. And then that you can put that into the equation we just did. You can put that in here, right in here for m, whatever that solution is. Okay? Alright. Hopefully our video will look pretty good. Alright, let's go ahead and practice this. This should be, I hope, second nature for you. If you need to label these, you can. X1, Y1, X2, Y2. And subtract the y's on top. So 7 minus 1 over negative 3. Remember, if I start over here, this one minus this one, then I have to do the same thing on the bottom. This one minus this one. I have to subtract from the same coordinate to the same coordinate. 7 minus 1, negative 3, minus negative 6, giving us 6 over, this would be plus, so negative 3 plus 6 is 3. 6 over 3 simplifies to 2. And then putting this in y equals mx plus b, well, it starts with this. Y minus, you can pick any of your y's. We'll just do this one. We'll do this coordinate to get the equation. You don't need both to get the equation. Just one of them. The slope was 2. Since that was a negative 6, it's going to change to a plus 6 because these are originally minuses. Okay, make sure you remember that. Y equals, and then I'm going ahead and switching all this in one step. Distributing first, putting all that, and then I'm going to add 1 to the end. 2x plus 12 plus 1 giving me, yeah, that's it. Y equals 2x plus 13. Ding, ding, ding. All right. So that's the idea. It is difficult to get this in Desmos. Well, let me just think about this. So here in Desmos, you can put in these 2 points. You can kind of imagine where this line is going to go, where it's going to cross the x and y axes. But it doesn't really give you the definite line or definite equation. So in a little bit, I'm going to show you what we do when we only have dots. And when we need this equation, there's a way to do it in the calculator, but we're going to get to that in a little bit, not quite yet. So just go ahead and do it this way. Go ahead and try these 3 out, 4, 5, and 6 on your own to make sure you're good with that. And press play, pause it, and then press play when you are ready to see the answers. Alrighty, here you go. Solution number 4. And solution to number 5, as far as equations go, the first part slope is right here in front of x, in case you need to check that. And then number 6 came out a little bit different. The slope came out to 0. You plug a 0 in for slope and then a point into x1, y1. You get this. Y plus 3 equals 0, giving you just y equals -3. So that was a horizontal line through -3. Okay, now moving on to, yes, word problems. It is really important to be able to do word problems and interpret these problems into equations. Okay, so we're going to start with this. A cab ride costs $4 plus $1.75 per mile driven. Okay, write an equation to represent the cab fare and define your variables. So cab fare, we'll do the cab fare will be our C. And then we know that 175 per mile, so we would have to multiply that by how many miles we have. So mile will be our M. So it's $4 plus this. Okay, so this should be a fairly simple one. C, the ride will start at $4. And you'll add $1.75 per mile, so times M, times each of my miles. Okay, and then if you're not sure, take a step back and ask yourself, okay, does this make sense for my scenario? Yes, it does. Okay, so that's really all you got to do. Write your equation out. Okay, then of course, so they give you a scenario that you need to use it to solve. If Clay's destination is 17 miles away and he has $30, will he make it? So his destination is 17 miles, so that's going to be my M. And he has $30, will he make it? So we want to know how much the cab fare is going to be and then just figure it out compared to the 30. So we do not plug in the 30 because we just want to see what this number is and compare it to the 30. Okay, so we just do $4 plus is $1.75, but that is multiplied by the definite number of miles, which is 17. And then you put this in the calculator and you get 33.75. So that's how much he will be charged for going 17 miles. Will he make it? The answer is no. He is short $3.75. He about people before somebody jumps in and gets a cab ride and then somebody else ends up paying for it because the doofus didn't bring enough money with him. Yep. Oh, bummer. And if you're, a nice person, you'll bail the guy out. But if you're not, yeah. All right. So good with that. Let's look at another one just to be sure, because I know word problems can be a little bit intimidating, especially if you don't really know what they're talking about. All right, the Joneses, they are purchasing a new home. Exciting. The closing costs are $249. Wish mine was only that much. plus 3% of the purchase price of the home. So 3%. Now, one important thing to do is anytime we have a percent, we can't just throw it into an equation as 3. We have to change it to a decimal. That is vital. So, of course, decimal is here. So, to percent per 100, so you move it over 2 places. So that's really 0.03. Okay, always do that whenever you are given a percent of the purchase price. We'll call purchase price P. Why not? And then the closing cost will be the C. So we have this plus this amount plus this. And this is, when it's of is also multiplication in this case. Okay. It is multiplication, 3% of, so that's times the purchase price. Okay. So we're, of course, getting ready to write the equation to represent the total closing cost to find your variables. I'm not as worried about that part. I just want to see a good equation. So the cost will equal $249. That is the amount of money you got to pay in order to get them to pay the people to give you a house, basically, who do all the paperwork for you. And then you add 0.03 times P. So 0.03P. Yep, here you go. All right, now let's see what happens with the Joneses. The purchase price of their home is $195,000. And the sellers offered $5,000 in closing costs. So this doesn't have to do with, remember, this equation we made only has to do with closing costs. So this is something else. This is extra. Okay, so this is just something else we're doing. The sellers offered $5,000 in closing costs. Assistants, will this cover all their closing costs? If not, how much will the Joneses need to pay out of pocket? So we're going to use the formula and see how it works out. So we don't include this amount, okay, but we put it in for P. That's where we need it. So plus 0.03 times 195. All right, using your calculator. I'm going to do this part real quick. So what is 3% of $195,000? That is $5,850 plus that initial $249. So they got that base amount plus that person wants to make this much money, $5,850. So the more expensive the house, the more money they make, obviously. So then add $249 and you get $6,099. So let's see. So that is closing costs. That's on top of the $195,000 that the house actually costs. Yeah. All right. So if the sellers offered $5,000 in closing costs, will it cover all their closing costs? Clearly, no. The Joneses need to pay okay, so what's the difference here? $6,099 and $5,000. They have an extra $1,099 that they gotta pay. All right. So, why don't you guys go ahead and try number 9. It'll be similar, okay? And see if you can figure it out and press pause and then play when you are ready to see the answers. All right, go for it. All right, so this is a pretty tricky problem. It is different from the previous two. So we have this original candle, and it's basically deteriorating as it burns, right? So to see how much it will be left after a certain amount of time, this will definitely be a subtraction problem. So we're going to start out with the amount of candle left will be C. And then 2.25 ounce candle will subtract by how much every 5 hours? 1 ounce. Okay, so that's 1 out of 5. So you can see this as 1 out of 5 and then times the H. to kind of illustrate this on one level, so is substitute in a 1. Say, okay, let's pretend, because one is easy. I'm going to burn the candle for 1 hour. So if this candle burns at 1 ounce for every, actually, it says 5 hours. I'm changing that. What if I burn it for every 5 hours? I want to know, that's the 1 ounce. So if I burn it for 5 hours, I'm going to lose the 1 ounce, right? So if I in other words, if I plug in an H and make that a 5 hours, right? H will be my hours. Then I'll have 5 here, and then this 5 and this 5 will cancel out, leaving you with 1. So the 22.5 minus your 1 ounce. So that's like just a test, okay? Let me just write out what I test for 5 hours. We know that this says in 5 hours, 1 ounce will disappear. So I'm doing this test, 22.5 minus 1/5. And then my test for my hours is 5. And then I'm eliminating the 5s because they can reduce, giving me just 22.5 minus 1. And that's what it says. For every 5 hours, it'll reduce 1 ounce. So that's a test to make sure my equation makes sense. That's all it is. I'm just, doing a little preview to see if it makes sense, and it does. Okay, now I'm going to use this. How many hours will the candle last? So we want, of course, this, but we want 0 candle left, right? So if we plug in 0, well, 0 equals 22.5 minus 1/5 H. So we want to get H by itself. Minus 22.5 equals negative 1/5 H. And then to get this away, we would multiply it by its reciprocal since it's a fraction, and the negative. So multiply by negative 5. Multiply this side by negative 5. Alright, so I know that's going to come out to be positive. 22.5 times 5 is that, and then that's my H. So that's how many hours, so 112 hours and a half is how long it'll take the candle to disappear. So how much candle left? Again, just make that a 0, because we don't want because we're assuming the candle is completely gone. Okay, yes, that was a tricky one. Alright, we have a few more in standard form. Josh bought 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost and define your variables. So if it's standard form, that's my AX plus BY equals C. Alright, so total cost, let's go ahead and make that a C. That's my total cost. You have 3 bags of potting soil and 10 bags of mulch. Okay, potting soils, that's easy. When you got 2 things, that's your X and your Y. So the cost will be 3 times X. And then, of course, add, because we would add this much money. And 10Y. And that's about it for that. Now, application. If Josh spent $40.91 and mulch cost $2.75 per bag, how much was a bag of potting soil? Alright, so this is going to be the C. And the mulch cost was my 10. So this is my Y. They're telling me that I got 10 of them times 2.75. This will be the cost of that. And then I'll have the X left and I can solve for that. So how much was a bag of potting soil? In other words, we want to know what is X. Alright, so 40.91 equals 3x plus 10 times 2.75. So that should be 27.5 minus 27.5. Is that? Then divide that by 3. And x is equal to $4.47. And there you have it. Alright. Why don't you go ahead and try number 11. Hopefully this one won't be too messed up. It shouldn't be as odd as this other one was. Alright, go ahead and pause the video. Okay, here you go. So the quarters were each worth 0.25 and the nickels are each worth 0.05. So since you use those values, since they want the value of the coins. Alright, so here's your equation. And then you plug in the $5.50 at the beginning, since that's the total. Plug in 17 for the number of quarters, which is x. And then you're finding y. Y ends up being 25. Okay? Alright. Why don't you go ahead and also try number 12. Okay? So 12 should be similar. Alright. Pause the video. Alright. So I made my pretzels an x and popcorn a y. The total sales, I just put S. S equals 4.5x plus 3.25y. Then over to the scenario, they sell 137 of the x's of the pretzels. So plug that in for your x. And they want to make at least $1,000. So to reach $1,000, you would solve and get y by itself, figure out what y is, and you should get this, 118. Okay, now we're getting into the nitty-gritty stuff. Alright, so this is stuff that really important and will have some new stuff input here into Algebra for Algebra 2. So a scatter plot, you should know what that is a relationship between variables where you have a bunch of points plotted on a graph, but they are not in a line. They are scattered, right? So if it's a positive correlation, the points will do something like this. They will increase like a positive slope. Negative correlation will, of course, look like a negative slope. And no correlation and it's just all over the place. Okay, so we're going to figure out how we can find the line of best fit using the calculator. And we have, you've probably heard of line of best fit. But we're going to focus on this in the calculator way. They definitely like to put this stuff on the SOL test. And the line of best fit is why it's helpful, of course, is to predict future values or other values that we don't know. So the table is right here, and we're going to show the relationship between the depth. So usually on a table, this is my y or x value, sorry. And then this is the y value. So we're always going to assume that. So that means on my scatter plot, my x value is usually where? Yeah, down here. This is usually your x-axis, and this is usually your y-axis. So don't deviate from that, okay? You want to put the d, and the d is depth, on the x-axis, because that matches, and then the temperature. See if I can write sideways. That's kind of hard to do. So let's go ahead and plot these points. Starting with our x's, let's see, we want to go up to 15. So we kind of have to adjust possibly down here to see where we're at. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, so they did give us enough. Okay, so we could leave that as the way that they are, as they're in ones, but we're going to have to do something different up here. Our lowest value is 76, and then our highest value is 85. So I'm going to have to do some jump in. Just to remind you, what you can do is you can put this little zigzag in your graph to show that I have some space, and then I'm going to do, we can start it at 75. Let's do that. Say, okay, this is 75, and I probably have room to go to 85. Yeah, I should. So 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85. So I'm just going to go ahead and put my intervals on here. But just remember that zigzag, and you can put it on either axis or both axes if you need to. So we'll go ahead and graph these. 0. So 0, of course, is here. 0, 85. Let's just change up the color so you can see distinctly where my points are. 0, 85, 4, 82. And of course, go ahead and be doing this at the same time that I am on your paper. I should have just write those down here. Alright, I'm at 7 and 81. And 10 and 79. 12 and 77. And 15 and 76. Okay. Alright, there is the scatter plot. And what we're going to do is use the ordered pairs to write a line of best fit. Alright, we're going to kind of do this by hand and then see how we can do this in the calculator. So we'll take two ordered pairs. Typically you will pick the first one. I mean, you can pick the first and the last. It doesn't really matter. Let's do that. Let's pick the first and the last. 0 and 85 and 15 and 76. And just to see, yeah, that's about making my line, right? So, first thing we got to do is find the slope. So we're going to do that. Find the slope. 76 minus 85 over 15 minus 0. Why do we need the slope? Well, if we're going to make an equation, we need a slope. 76 minus 85 is negative 9, correct, and then that's 15. Alright, so that's our approximate slope. Can that simplify? Yes, it actually can. Negative, I can divide both by 3. Negative 3/5. Alright. And then we can take the equation and say, alright, if I want an equation, I'll just use this point, y minus 85 equals, so a point and a slope. Again, the name of it, negative 3 over 5. Oh no, I'm having some lagging. Oh gosh. I think I got it. Distribute. That times 0 is going to be nothing there, and then I just have to move the 85 to the other side, and that'll give me, oh, I'm putting this in y equals mx plus b form, because again, that's usually the best one, and why not? Alright, so there you go. So there's an equation for this scatter plot. Okay? And then the next part says predict the temperature of the lake at 25 feet. So 25 feet is given to me. Is that a temperature or is that a depth? Of course that is a depth. So that's an X. So I want to get the temperature, which is the Y. So my Y is going to stay. It's unknown. Plug in for X 25. And again, 25 is way off the graph. So that's why we're using the equation to do this. And you get 70. Definitely real world applications here for, you know, some kind of job where you gotta, you know, make predictions like this. Definitely. Okay, we're gonna dive into the calculator stuff, so go ahead and get ready with your calculators. So you got your calculators. I will go ahead and show, I guess, Desmos first. Now the instructions that are given here are for your handheld calculator. So you could, if you want to go ahead and do it this way, you can do it either way. I'm going to show both, but Desmos will be a lot easier to see because it's on my computer. So let's start with that. Now I'm going to write these directions below. So what you're going to do on Desmos is you're going to start by writing out the equation with variables only. And it's going to look like this. So you're going to type in, well, the equation we want is y equals mx plus b. But in Desmos, you need to put a 1 with the y and the x. So it's y1, and then instead of equals, we're going to do the little squiggly sign. So if you look on your keyboard or your Chromebook, it should be above the shift key, and you have to push shift and that button. Okay? So it should be next to number 1. So get that to show up. And then mx, and then just push 1. All you have to do is push 1 on your keyboard. I'm just only using my keyboard. Y1, squiggle, mx, and then plus, and then b. So what this is going to allow is it's going to give me the values that I need for my m and my b once I create my table. So this is really cool. Alright, so I'm just going to jump down to another line, and then I'm going to put plus, I wonder if it'll do it now. Put plus sign, click the plus sign, and then table, and it's going to bring up a table. Now, what you have to be careful of here, though, is we want the table to represent this graph. So we have x1 and y1, but they automatically put in x2 and y2, so we want to fix that. So go up there, just put your cursor, delete, and then push a 1. Same thing here. We want it to use the 1s. Alright, and then we're going to type in our values. So that is going to get us started. So you put all your x values here and all your y values here. And then you'll see up here it's going to change and tell you what m, the suggested value for m is and what b is. Okay? Alright, if you're doing the regular calculator, then you are going to do these steps right here. So the first thing you're going to do is push stat. Stat is right here in the middle of your calculator, just to give you an idea. So push stat, and then push enter, and then you're going to see this, okay, list 1, list 2. To easily, if you have numbers already in there, put your cursor all the way up to L1, like this, so L1 is in black, and then push clear, and then enter. And then it'll automatically delete all the values in there, so that there's a quick way to delete all of your numbers by highlighting the list name and then pushing enter, or clear and then enter. Okay, and then so now you're at the same place pretty much that we are. So we're going to go ahead and do number 1. So if you want to go ahead and type these values in. So like I said, x and y really important. So when the table is going horizontal, x is usually your top, and then y is usually your bottom. So we're going to always do it that way. So go ahead and you can type these in the x column and these in the y column. While you're doing that, I'm going to write out the Desmos instructions for that. So in Desmos, and you can copy this down as well. You want to type in y, 1, squiggle, then it'll bring out that. But remember, you've got to change those to ones. And then enter your values. Okay, there you go. So there's your instructions for Desmos. And I'm going to go ahead and switch over to Desmos and start putting my values in. Alright, I'm typing in 63. If my computer will stop being slow. There we go. 115. Why are you giving me suggestions? Don't give me suggestions. Okay, let's make sure I got that all. 63, 115, 153, 192. Make sure you don't leave anything out. Always go back and double check. You typed everything in there. And then the Y column. Okay, there we go. Here's what the graph looks like. So you can mess with your graph. And then up here, so on Desmos, this is what you're looking for down here, parameters. M. So it gives you, you put in all these random points, and it's telling you what the slope for best line of best fit. This is basically the calculator is doing line of best fit for you, giving you your slope and your y-intercept. Okay, so this is how we're going to write our equation. So usually we're going to put answers to the nearest. We're going to put 2 decimal places, so that's to the hundredths place. So 1.83 will be our slope, and then negative 16 point. We're going to round this up to 5. 16.50, and that'll be our B, okay? So Desmos, write all there on one screen, okay? And then if you're looking at the TI calculator, you see these directions and next. So after you put in those lists, it tells you over here what to do next. You push stat, then you go over to calc, you choose the one that says linear regression, hit enter, and maybe twice. To get, and it'll give you the equation very similar to the way Desmos does. It'll say, here's your form of the equation, and then it'll give you your M and your B, and then you just plug those in. So, since we've already been given our answer, let's just write it out. Y equals, and the slope was 1.83 x. So we get rid of the squiggle and all that. That's just the notation we needed to put it in Desmos, what we need to do. But when we do it regularly, change it back to an equal sign, plus, oh, it was negative, plus negative 16.50. So we're going to do, again, 2 decimal places for these type of problems, okay? All right, gave us, and this is called the regression equation, all right? Then we have another problem to go along with it. Predict the number of suitcases. Let's see, suitcases is S, so that's my Y column. On an airplane with 500 people, and that is the P, which is my X column. Alright, so we just take this equation and plug those values in. We want to know Y of 500. And I can just quickly put that in the calculator. You can put in either calculator, it doesn't matter. And you get 898.5. So 898, that rounds up to 899. So something in that area. Okay? Alright, hopefully that doesn't seem too bad. Okay. Let's go ahead and at least we'll just do the table again for number 2. Just to make sure we're good with that. So again, this is, you type all this in first. This stuff will just automatically show up. Okay? And this can just come right from your keyboard. Okay? You just literally type in Y1. You don't have to look. I mean, you can, but you don't have to worry about this keyboard on this, which is really nice because it can be hard to find stuff in here. Just literally type in on your keyboard Y1 squiggle MX plus B. And then on the next one, we're going to change up our columns. Alright, so number 2, my top row is my x's 0, 3, 6, 9, 12, 15, 10.7, 11.1, 11.9, 12.5, 13.2, ooh. Okay, look at that. Man, technology is amazing, isn't it? So you got those black dots, and then you've got your values right here that they're telling you to put. Okay, so why don't you guys go ahead and try these, and we'll check the answers. But one thing I do want to show you on number 2, and you'll see this often, is they've got the table. But they've got the year 0, 3, 6, 9, 12, 15, and during certain years since 2000. Okay, so they're counting year 2000 as the 0 year. Okay, so then 2003 is what year this really is. 2006, you get the idea. Now look what they're going to do over here on this. Predict the population in 2025. So that is going to mean that you have to adjust this number, okay? So you don't want to put 2025 here and plug that in for your x. No, you don't want to do that. Okay, you got to be really careful. You got to adjust this and put just 25. So you got to compare to what that number will be like in your actual table. So that would be a 25. So change this, in other words, to a 25. Okay? Alright. If you see that again, you may have to do that again. Now this one looks like it's doing it normal, so you should be okay just putting these straight in the years that they are and then plugging in this in the way that it is. But just watch out in case they adjust the years and make them smaller like this, then you got to also adjust this one too. Okay, I want you to go ahead and pause the video and work through these, and then when you are ready to see solutions, press play. So go ahead and pause. Alright, here you go with your solutions for number 2. Here's number 3. This is your equation. Plug in 2020. Highest paid Major League Baseball player. Well, with COVID-19, who really knows if that actually happens? Probably unlikely. Alright, and the table below will show the mileage and then the value of the car. So as you can see, mileage goes up, value of the car goes down. Here's your equation. And then here is this response, the value of a car, be about this much. Alright. that's the end of this particular unit. So, thanks for watching. See you next time.